Have you ever looked at some massive piece of software and just wondered, how on earth is that even built? How does it not just collapse under its own weight? Well, the secret is this surprisingly simple idea, one that I bet a lot of us learned as kids.
Hello and welcome to Kognito Key. Today we're going to dive deep into that very idea.
So, let me start by asking you something really simple. Have you ever played with Legos?
You remember that feeling, right? Taking all those small, standard, colorful bricks and building something huge and incredible from them, like a castle or a spaceship, or really anything you could possibly imagine. Well, that core idea, that's exactly what we're talking about today. Because it turns out that brilliant strategy, building big things from small, standardized pieces, is precisely what powers modern software engineering. So let's talk about software's very own Lego blocks. The official name for this concept is modularity. And really, it's just a fancy way of saying we take a big, complex system and we break it down into these smaller, separate components that we call modules. The best part is, each module can be built all on its own, and then, just like Legos, they just click together to create the final product.
But why? Why do we even need to break things down like this in the first place? What problem is this actually solving? Well, it's all about taming the absolute beast that is code complexity.
To get it, just imagine the complete opposite of modularity, a monolithic program. This is just one giant, tangled blob of code. A single massive file where every little thing is connected to everything else. You can imagine that trying to understand it, or find a bug, or even just add a tiny new feature, it's a total nightmare. It's slow, it's confusing, and it's incredibly risky to change anything at all. And this really shows you the difference, crystal clear. On one side, you've got the monolithic approach. It's hard to understand, an absolute headache to debug, and teamwork just crawls because everyone's tripping over each other in the same giant code base. But then you look at the modular approach. The code is easy to grasp in small chunks, it's simple to debug because problems are trapped inside one module, and it lets teams work on different pieces at the same time. I mean, the choice is pretty obvious, isn't it?
Okay, so if being modular is the way to go, how do we actually create these perfect, independent modules? Well, it really comes down to a classic saying: good fences make good neighbors.
In the software world, that fence is all about managing something we call coupling. Coupling is just a measure of how much one module depends on another. And the goal here is to have as little connection as possible. You want low coupling. Think of it this way. Instead of a payment module just reaching into a user module's private data to grab an address, it makes a polite, official request through a well-defined channel. They only interact in these really predictable, controlled ways. And here's the flip side. While the connection between modules should be low, the connection inside a single module should be super high, and we call this cohesion. It just means that everything inside one module should be laser-focused on doing one thing and doing it really, really well. A user login module should only handle logging in and out. It has no business also trying to process payments, right? That's high cohesion. So if you remember one thing from all this, let it be this golden rule that every developer lives by. You always aim for low coupling between your modules and high cohesion within them. That's the real secret to creating these clean, independent, and powerful little building blocks. You know, what's really fascinating is that there's a balance to be struck here. As you can see, if you have too few modules, you're stuck in that monolithic nightmare, and your costs are high because everything's so complex. But if you go crazy and create hundreds of teeny tiny modules, the costs of just managing and connecting all of them can also go through the roof. The real key is finding that sweet spot in the middle. So when you actually follow that golden rule and you find that sweet spot, what do you get out of it? Well, you unlock the true modular advantage. And trust me, the benefits are huge. The advantages are just fantastic. Debugging becomes so much easier because bugs are contained inside one module. Maintenance is way simpler because you can update one piece without breaking the whole system. Teams can work independently on different things, which just speeds everything up. You get built-in damage control, so a bug in one module won't crash everything else. Testing is faster. And maybe the biggest one of all is this incredible potential for software reuse. So what makes a module perfect for reusing again and again? It's really simple. It has to do one single useful thing, and it must have those few clear, well-defined connections, that low coupling we were just talking about. When you build a module like this, you're not just solving today's problem. You're creating a tool that you can use tomorrow and the day after that. So the end result of all of this, of thinking in modules, is software that's just plain better. It gets built faster, it's stronger and less likely to break, and it's so much more adaptable to whatever changes or new features come down the line. So I'll leave you with a question to noodle on. Whether you're a developer, a manager, or you're just curious about how things get built, think about this. What part of your next project, big or small, could be its very own Lego block?
If you enjoyed this explainer and you want to get into more core concepts just like this one, please make sure you subscribe to Kognito Key.
And of course, don't forget to like and share this explainer with anyone you think might find it helpful. It really does help all of us build better together. Thanks for joining me, and I'll see you in the next one.